All right, so this is test taking, strategy, timing. So basically, when you start the test, you have, well, this is like, I'm giving myself unlimited time here, but test day certification, 4 minutes for that. Tutorial is 10 minutes, so that's 14 minutes that you have. So in that 14 minutes, what I'm going to do is I'm going to write things out on my scrap piece of paper, like basically things like, radical 2 is equal to this. Rad 3 is that. Log of 1 is equal to sine of 0, which is equal to cosine of 90, which is equal to 0. Log of 2 is equal to 0.3, which is, 1/3 basically. Log of 3 is equal to 0.5, which is equal to sine of 30, which is equal to cosine of 60. Log of 5 is equal to 0.7, which is equal to sine of 45, which is equal to cosine of 45. Oh, wait. Okay, there it is. Sorry. Log of 7 is equal to 0.9, which is equal to sine of 60, which is equal to cosine of 30. Log of 10 is equal to 1, which is equal to sine of 90, which is equal to cosine of 0. I'm also going to write, because fractions are way better to deal with than decimals, so I'm just going to write some fractions out. This 1/12 happens to also be equal to R in liters times ATM over moles Kelvin. Let me see if I can make this bigger. What else? Oh yeah, so and HC, like Planck's constant times the speed of light. Well, Planck's constant, I can just rewrite the 6.626 as 20/3. So when I multiply it by the speed of light, the 3's cancel out, so I just get this. That's a super useful calculation that you can just memorize. Yeah, and then I guess just knowing certain amino acids maybe that aren't as intuitive. Also, this formula comes in handy. And I would also write out a table for optics. So I know that, diverging will always be SUV, smaller upright virtual. For converging, it's basically just going to be this pattern of basically like a tiny inverted real image, smaller inverted real, same size inverted real, larger inverted real, no image, and then larger upright virtual. So this depends on where an object distance is at infinity. An object distance over here is greater than 2f. Object distance here is between f and 2f. Object distance here is, I believe, at... Oh wait, no. Object distance here is... Sorry, I'll just write it out. So here object distance is... Whoops. Object distance is at infinity. Here object distance is greater than 2f. Object distance is at 2f, which is the radius of curvature. Object distance is between f and 2f. Object distance is f. Object distance is within or less than f. And like sine and cosine, the image distances will be complementary. So image distance here is greater than 2f. Image distance here is infinity. Image distance here is at 2f. Wait, my bad. No, oh, wait, this is on opposite end. Sorry. This is greater than 2f. This is at 2f. So this is like the cosine 45 thing where both object distance and image distance are at 2f. Here, image distance will be between the focal length and twice the focal length. And then here, image distance would be at the focal length. So I would just write like something like this out, and then I would do like a breathing exercise essentially. Like just, breathe, inhale for 4 seconds, exhale for 4 seconds, and just try to center yourself and get yourself to focus on just what's in front of you. So anyway, I will start the test. So first thing I want you to do is go hit navigation and go to question 9 and then answer 9 through 12. So answer the discretes first. Okay. And this is how you should answer them. So if anything takes too long, guess and flag it for review. And the idea here is to basically finish the test with 10 minutes left for a review. So you can basically spend more time on the questions that take more time. So I'm just going to quickly do this. Let's see. Absorption of ultraviolet light by organic molecules always results in what process? I'm going to say it's that. So that seems to take more time. So I'm just going to flag it because I want to finish, it's 4:40. I want to finish this by like 5 or maybe even sooner. Half-life is the time it takes for pretty much that. Oh, wait, that, because of the daughter nuclei, okay. This one, is that. All right, now I'm going to go, so I finished the first round of discrete, so now I'm going to go to questions 25. So I'm going to do these discretes. So the idea with the discretes is that when you do them first, there's 16 discretes total, and 16 over 59 is, well, it's like 72%. So if you do the discretes first, you will have finished greater than a quarter of the entire test, and you'll have that done and out of the way, and then you can attack the passages with greater confidence. So okay, I'm gonna think it's that. Oh, this is like Chargaff's rules or whatever. I don't remember which ones they are, so I'll flag it. I think the purines are the bigger ones. Pi stacking. I know it's due to like greater. GNC has, GNC has 3 hydrogen bonds, A and T do not, but A and G I believe are. Is that pi stacking? I'm not sure. Whatever. I flagged it, so you go back to it. So blah blah blah. Estimate its relative vapor pressure. Well, molecular weight affects the boiling point. Relative vapor pressure. I don't know. Maybe that. I'll flag it. 3 fatty acid ester length. I mean, that's a triacylglycerol. These are, well, it's storage lipid. I'm going to flag it just in case. All right, now I'm going to hit navigation again. I'm going to go to questions 44. So you can just memorize these where the discretes are. Okay, so let's see, blah, blah, blah. Least likely, okay. systole, diastole. Okay, that's true. That's true. I mean, I think that's true, because then it creates turbulence, so I think that's not true. I'm going to flag it just in case. Okay. That's true. Chargaff's rules. They're anti-parallel, so that's not true. Wait, what? Oh, they're saying what's true, my bad. This thing over here, ion C were released. Okay, so it's going to be pushed away from here, so that vector goes here in this direction. And this one goes there, so it should just go to the right. Oh yeah, I should have wrote 1.6, like, that's equal to, I think, 5/8. Yeah. No, 8/5. So I'll add that to the thing. 1.6 is equal to 8/5. So, you know, just because 1.6 is messy, and I think it's better to use fractions like this than to just estimate that it's, or approximate it to 2. Okay, so let's see. That's the total charge. So this, how many times does this go into that? I guess in this case, since 1.6 goes into 3.2 twice, that makes it simpler. So it'll be 2, and it's -9 minus -19. So basically 19 minus 9, so times 10. So 2 times 10. Yeah, electrons, you can't move protons. All right, now I'm going to go through the last discrete, which I think are questions 55. Wait. 57 to 59, so okay. Battery powered resistive circuit, so electrical, chemical to electric, okay. Hydrogen secondary structure. Hydrogen bonds between the side chains, I believe. Side chain and backbone carbonyl, I believe. I'm gonna flag it just in case. Parallel with that. So, oh yeah, so I mean, I have this memorized, but for you guys, I'll write it down. So basically this equation, when you do like a reciprocal sum, can be simplified as the product over the sum. So 60 times 20 is going to give me 1200 over 60 plus 20, which is 80. The zeros cancel. Well, okay. 4 goes into 8 twice. Goes into 12 3 times, or 30, whatever. And then this is going to be 15. So that's that. All right. And so, okay. Then you basically go back to the passage and you answer the passage questions. You know, with now you can attack the passage questions with the knowledge or the confidence that you've already answered 16, or basically 28%, I believe, of the entire test is already done when you're approaching passage 1. Because most people, if they just start with passage 1, which is usually going to be a hard passage on the MCAT, they always do that because they want to psych you out and they want to damage your confidence level for the rest of the exam. So if you do the discretes first, you will have done something that the test makers have not accounted for, and you can attack, you know, passage 1 with additional confidence. So it won't have the ability to psych you out. And you know, you should answer the passage questions by going to the question first. So here, this doesn't even make me, well, wait, which atom is a type of covalent? Okay, so this is how I would answer this, because they're talking about something in the studies. So covalent attachments of AMC, I'm going to look for AMC, okay? AMC right there. So, okay, so it's this over here. It's a fluorescent tag, okay? So it's going to be something that you add to a molecule to have it fluoresce, basically to have it shoot some light at us for us to get some type of measurement. So they're saying that, okay, so this is AMC, the molecule. So what atom is the site of covalent attachment of AMC to the model tetrapeptide? So, okay, let's see, tetrapeptide, blah, blah, blah. Tetrapeptide, is it this thing over here? Peptide, succinyl, blah, blah, blah. So, okay. So generally speaking, right now, like I'm basically reading parts of the passage and it's all going into my brain. But since it's taking long, I'm just gonna click something and flag it and go to the next one. Because I was trying to find the tetrapeptide, I didn't see it. I could see a peptide over here, and it says they disconnect it through hydrolysis. So basically, if you connect it, it's through dehydration synthesis. So basically, it would have to add to something. My guess is, well, maybe 2 or 3, but whatever. Basically, I flagged it. So basically, the idea is to finish the, like, have seen. I want you to have seen every single question, and to see every single question with 10 minutes left on the clock, and so you can spend that extra 10 minutes that you have going over like the questions that you have flagged. So this one, light energy, all right, so this, you just need to find like their frequency or wavelength over here, so you don't actually have to do anything else. So I see fluorescence emission. Also, you should have your hand on the Alt button, like so I have my left thumb on the right Alt button. It's like Control or something Option or whatever if you're using a Mac. So I have like, yeah, my right thumb on the rightmost, the Alt button on the right of the space bar, and my index finger on the H. So, and when I highlight, I also just double click on the word and then hit Alt H, and then it highlights it. So that way I don't have to, like, do this and then go and hit like the highlight button. I can just double click on it and highlight it. Double click on it, right? So anyway, so So anyway, I highlight 440 and 360. So emission basically works by the pigment or whatever, fluorophore or whatever. It absorbs light at a certain frequency, or whatever, gets excited at a certain frequency, and it absorbs, or it rather, so it basically is resonance stabilized through pi, conjugated pi double bond, so it can absorb light at a higher frequency than it emits. So they're asking what expression gives the amount of light energy that's converted to other forms. So if it absorbs or is excited at 360 nanometers and emits it at 440, I'm going to try to find the difference between the energy levels of both of these. So it'll be that. So it's Planck's constant times the speed of light, and you divide it by the wavelength, which is the same thing as multiplying it by the reciprocal. So it's the reciprocal, so it's the same thing as dividing here. So it's 1 over this wavelength minus this wavelength. Concentration of the substrate is larger by what factor? So concentration of the, so I'm going to look for like numbers essentially. So porphyrins are at, wait. Protosome, oh, it's stuck on that. That's stupid. Okay. Protosome, blah, blah, blah. So basically the porphyrin basically can work to inhibit the activity of a protosome. Okay. Porphyrin compounds, these are just versions of this with these as R groups, I suppose. Chymotrypsin-like activity. Chymotrypsin is the, oh wait, protosome over here. I'm just going to click something and flag. All right, so here I don't have to look too much into it. I can just look at the literal thing over here and count the double bonds. 1, 2, 3, 4, 5. So, oh, there, that isn't a choice. So, the fluorophore used in the experiments. I mean, it should be that. 1, 2, 3, 4, 5. Then we have 4 and 6 here. I'm just going to go with, oh wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there were 5 whatever double bonds, but they're asking for the number of carbons, so that's going to be that. All right, already on passage 2, so I'm just going to look at lactase, wherever that is. This is the active site of lactase, and what? There seems to be, this is like, I think, methionine or something like that. There's a lot of this guy over here, so basically, what is this? So I'm pretty sure this is a, it might be a proline, so, oh, that's not even a choice, so never mind. So it's definitely not phenylalanine. Tyrosine, cysteine, I think cysteine is that one or something. So I think it's histidine, actually. It's basically whatever this guy is. So, yeah. So I'm pretty sure about that one. If I wasn't, I would flag it. Structure of the, all right. Compound 3, so I'm gonna have to like look at stuff here. So compound 3, and they're saying, all right, this requires me to look at too much. I'm going to just flag it. Oh yeah, but always guess something and flag it in case you run out of time and you don't have time to, you know, randomly guess. Data in table 1. Oh man. Okay, so table 1. So compound. So I need to decipher if compound 1 is acid or chloride or something like that. Wait, chloride seems to not have an effect here. But if you increase it here, it does have an effect, apparently, for compound 3. Wait, compound 3 without it at the same pH has that rate, and then compound 3 at the same pH with some chloride, it's like a third. So chloride should decrease the activity, so chloride, so basically I also have my, pinky on the S, so I do Alt S, because I know that chloride decreases the activity, and these both have that. So let's see, now acid basically is going to be reflected in the pH. So now I can compare this to this. So let's see, the rate at a higher pH without any chloride there is decreased significantly. So acid and chloride, acid increases the activity and chloride decreases the activity. There we go. So again, see, I did not read any of this because I simply don't have to at this point. Concentration of enzyme for each experiment was that. Okay, so what is Kcat for reaction? Okay, when compound 3. All right, this might require me to read some stuff. So I'm just going to guess and flag it. So already did these, right? Bam, already on passage 3. Okay, I'm gonna finish in like 3 minutes. So side chain tryptophan, largest CD signal when in the near UV region when, okay, UV CD, okay. Largest CD signal in the near UV region when it seems like the largest signal is alpha helix, part of an alpha helix. I'll flag it just because I didn't really read anything. I just looked at it and made a guess. Which one would be in the far UV but not the near UV? So I think that has to do with ellipticity or something. So I didn't really read into that yet, so I'm just going to guess, flag it. Okay, so basically when something absorbs a photon of energy, which will be closer to the ground state. So this is basically asking, what energy level. I'm pretty sure it's going to be the aromatic one. So the absorbed photon energy is going to be lower, I believe, because it resonance stabilizes it, but I'm going to flag it. And basically I'm just going to go like this through the entire test, and yeah, that's basically what I would do. This is the stuff I would write out, and I guess I'll continue this series at another date, but hopefully this was helpful.